Hi guys, in the last lecture we saw the concepts of differentiability and the mean value theorems. In the mean value theorems we saw three types of theorems: Rolle's theorem, Lagrange's mean value theorem and Cauchy's mean value theorem. So in this lecture what we will do is, we will look at some of the problems relating to those concepts so that you get a good grasp of how to apply these problems or how to apply these concepts. So in the first problem, if you see, I have been given a function fx is equal to 1 by 1 plus mod x. We need to check its continuity and differentiability at x equal to 0. First, let us expand the function definition based on mod x. I told you mod x is equal to x when x is greater than 0, minus x when x is less than 0, and 0 when x is equal to 0. So based on that, I can write down the function definition fx. It is equal to 1 by 1 plus x for x greater than 0, 1 by 1 minus x for x less than 0, and 1 when x is equal to 0. Now if you want to check the continuity, you will calculate the left hand and the right hand limit. So the left hand limit, if we talk about, we will take limiting x tending to 0 minus fx. If you are just below 0, that means you will be using the second definition. So it will be limiting x tending to 0, 1 upon 1 minus x, which will come out to be 1. If you wish to calculate right hand limit, you will keep limiting x tending to 0 plus fx, which will be limiting x tending to 0. If you are just to the right of 0, you will use the first definition, that is 1 by 1 plus x, which will come out to be 1. Now if you see, the left hand limit is equal to right hand limit, as well as it is equal to the function value at 0. So my function is continuous. Next I have to check about differentiability. For differentiability, I have to derive the left hand and the right hand derivatives. So let us first calculate the left hand derivative. How will you calculate left hand derivative? Limiting h tending to 0, f of 0 minus f of 0 minus h over h. So it will be limiting h tending to 0. What is f of 0? 1. What is f of 0 minus h? That is just below 0. So we will use this definition, 1 upon 1 plus h, because we are keeping minus h by h. So it will be 1 plus h minus 1 over h 1 plus h. So this h will get cancelled. So it will be 1 upon 1 plus h, limiting h tending to 0, which will come out to be 1. Okay. Now if you calculate the right hand derivative, for right hand derivative I will use the function definition above 0. The right hand derivative will be limiting h tending to 0, f of 0 plus h minus f of 0 by h, which means f of 0 plus h will be limiting h tending to 0, 1 by 1 plus h minus 1 over h. So it will be limiting h tending to 0, then it will be how much? 1 minus 1 plus h by h 1 plus h. So it becomes limiting h tending to 0, it will be minus h over h 1 plus h. So this gets cancelled out, so it comes out to be minus 1. Now as you can see, the right hand derivative is minus 1 and the left hand derivative is plus 1. Since both are unequal, so it is not differentiable. That is, this function is continuous at x equal to 0, but it is not differentiable at x equal to 0. Is it fine? Moving forward, in the next problem, it is asking me the mean value of the function fx is equal to under root x square minus 4. So lower limit is represented by a, upper limit by b. Then what is the value of fa? Under root 2 square minus 4, which is 0. What about fb? Under root 4 square minus 4, which is root 12. Now since both are unequal, which means I will apply Lagrange's mean value theorem. So what does Lagrange's mean value theorem states? That there exists a point C belonging to A to B such that f dash C will be equal to fb minus fa over b minus a. Now if you take the derivative of this function, it will come out to be 1 by 2 under root x square minus 4 into 2x, which will be x upon under root x square minus 4. Which means at x equal to c, the derivative will be under root c square minus 4. This should be equal to fb minus fa, that is root 12 minus 0 over b minus a, which is 2. Okay, that is root 12 by 2, which will come out to be root 3. Now let us square both the sides in order to determine the value of c. So it will be c square over c square minus 4 is equal to, it will be equal to 3. So it means c square will be equal to 3c square minus 12, which means it will be 2c square equal to 12, which implies c is equal to under root 6. This under root 6 value lies between 2 and 4, hence this will be my answer. Because the point C must always belong to A to B. Is it fine? So first of all, you will always have to judge whether to apply Rolle's theorem or Lagrange's theorem. If the two endpoint values is equal, you will apply Rolle's theorem, else you will apply Lagrange's mean value theorem. In the next problem, it is asking me the value of epsilon such that fb minus fa is equal to b minus a f dash epsilon. Now if you paraphrase this, this can also be written as fb minus fa over b minus a. Now this is the basic statement of Lagrange's mean value theorem. Now if you take the derivative of this function, it will be 2ax plus b. So at epsilon it will be 2a epsilon plus b. What about fb? ab square plus bb plus c, fa aa square plus ba plus c divided by b minus a. So it will be a into b square minus a square plus b minus a. Now if you resolve the first term b square minus a square as b plus a into b minus a, this will be reduced to a into b plus a plus b, which is actually equal to 2a epsilon plus b. This b gets cancelled out. So epsilon will come out to be b plus a by 2. That is the midpoint of the interval. That means Lagrange's mean value theorem will apply to the point that is lying at the midpoint. Moving forward, next it is asking me the value of c for which the function fx is equal to log x in the interval 1 to e. Now the lower limit is 1, upper limit is e. What is the function value at a? Log of 1 will be 0. What is the function value of b? Log of e, which will be equal to 1. Now if we take the derivative, it will come out to be 1 by x. So what will be the derivative at c? 1 by c. Now according to LMVT, derivative will be equal to fb minus fa, that is 1 minus 0, over b minus a, that is e minus 1. So c will come out to be e minus 1. Okay, and it will lie between 1 and e. So that is how you apply the Lagrange's mean value theorem. Moving forward, it is saying the Lagrange's mean value theorem cannot be applied to the function 2 minus x minus 1 raised to the power 1 by 3 in the interval 0 to 2. Okay. Now it is asking me the reason why you cannot apply this theorem. The first reason is fx is not continuous in 0 to 2. Okay. The next is fx is not differentiable in the open interval. Third is that f0 is not equal to f2. Absolutely the third option is incorrect. Why? Because whenever you are applying Lagrange's mean value theorem, the equality condition is not necessary. That means my third option is directly incorrect. Is it fine? Next is both A belongs to B. Actually, this should be A equal to B. Something like that. Okay, this is also incorrect. This is also incorrect. Now, first let us talk about the derivative of this function. What will be f dash x? It will be equal to, its power is 1 by 3. So, power is 1 by 3, derivative will come out to be x minus 1 raised to the power 2 by 3 into 1 by 3. That is, it will be 2 by 3 x minus 1 raised to the power 2 by 3. This will be my derivative. Now, if you keep x equal to 1, then f dash x goes to infinity. I told you the function is differentiable if its right hand derivative and the left hand derivative are equal and both are finite. Now, as you can see here, the derivative goes infinite. That means it is not differentiable at x equal to 1. But the necessary condition for Lagrange's mean value theorem is function should be continuous in the closed interval and differentiable in the open interval. Since it is not differentiable at 1, which is lying between 0 and 2, LMVT cannot be applied. So the answer will be B. Is it fine? Moving forward. Now it is asking the mean value C for the function fx equal to 1 by x, gx equal to 1 by x square. As you can see here, I have been given two functions, which implies I will apply Cauchy's mean value theorem. So, first of all, let us calculate derivatives of these functions. F dash x is minus 1 by x square. G dash x is minus 2 by x cube. Now, we know that according to Cauchy's mean value theorem, f dash c by g dash c will be equal to fb minus fa over gb minus ga. F dash c will be minus 1 by c square. G dash c will be minus 2 by c cube. Fb minus fa will be 1 by 2 minus 1 by 1. Gb minus ga will be 1 by 4 minus 1 by 1. That will come out to be minus half. It will come out to be minus 3 by 4. So it becomes 2 by 3. This will become C. So it will be C by 2 equal to 2 by 3. So C will come out to be 4 by 3. And as you can see, 4 by 3 is actually 1.33, which is lying between 1 and 2. In the next problem, it is asking me again the value of C. And now again I have been given two functions. That means I have to apply Cauchy's mean value theorem. Interval is minus pi by 2 to 0. So let us first calculate derivative of f, which will be cos x, derivative of g, which is minus sin x. Now if x is equal to c, then f dash c will be, f dash c by g dash c will be equal to cos c over minus sin c, that is equal to minus cot c. This should be equal to fb minus fa, that is sin of 0 minus sin of minus pi by 2 over gb minus ga, that is cos of 0 minus cos of minus pi by 2. Now sin of 0 is 0, sin of minus pi by 2 is minus 1. Cos of 0 is 1, cos of minus pi by 2 is 0. So it becomes 1. That is minus cot c comes out to be 1, which means cot c is equal to minus 1, which means c is equal to minus pi by 4. Again, it is the midpoint of the interval, because the midpoint of 0 to minus pi by 2 will be equal to minus pi by 4. In the next problem, it is asking me the value of the function y is equal to fx, which satisfies this condition. So here what I will do is I will assume x plus 1 by x is equal to u, which means if you take the square, it will be equal to x square plus 1 by x square plus 2x into 1 by x, which means x square plus 1 by x square plus 2. That means x square plus 1 by x square is actually equal to u square minus 2. So what I can say? Function of u is equal to u square minus 2. Based on that, I can directly say function of x will be equal to x square minus 2, just by the change of variable. Now it is asking me the value at 10. So f10 will be equal to 10 square minus 2, which will come out to be 98. So that way also I can determine the value of a function based on any given condition. In the next problem, it is saying let f be a function satisfying this condition. Now I have been given the value of f1. We need to find this expression. Now as you know, if you have a function exponential kx, then exponential of k x plus y will be equal to exponential of kx plus ky. That is exponential of kx exponential of ky, that is equal to fx fy. So if this property is true, then I can say fx is equal to e raised power kx, where I still do not know the value of k. But it is saying f1 equal to 3, which implies e raised power k is equal to 3. So now I know the value of e raised to the power k. Now if you see, it wants me to find the summation r is equal to 1 to n fr. That is, this summation will be equal to e raised to the power k, e raised power 2k, 3k, e raised power nk. Now it becomes a geometric progression with the first term as e raised power k and the common ratio as e raised to the power k. So the sum will come out to be first term, that is a, common ratio raised to the power n minus 1 over r minus 1. So it will be e raised to the power k, e raised power nk minus 1, e raised power k minus 1. Now I know the value of e raised power k, it will be 3. 3 raised to the power n minus 1 over 3 minus 1, which will be 2. So it will become 3 by 2, 3 raised to the power n minus 1. That will be the value of this sum. Okay. So such basic type of problems can also be asked on the functions. So now I have got a clear idea about the continuity, differentiability and the mean value theorems. In the next lecture, we will see what are the different rules to derive the derivative of any function. What kind of situations you can be in and how you will tackle each situation when you are finding the derivative.